Okay, good. All right. Okay, so I can't say any more of those things, Iris. Mic's on. All right, so I think it's 10 after, and since these sessions are kind of limited, I'm not going to waste any time. Okay, I just did. So, hello, good afternoon. Um, I'm Julie Lerman. I do some entity framework stuff. Is anybody familiar with entity framework? All right. Phew. So my reputation precedes me. Sometimes that's good, sometimes maybe not so good. Who's using Entity Framework Core already? Excellent. In production? Woo woo, yeah. EF Core 2, it's production ready. I'm just going to warn you that Mike's making me a little nervous, so I might keep trying to fix it even if it doesn't look like it needs fixing. So the other half of what I'm going to be talking about is domain-driven design. Who here is familiar with the concept of DDD? Oh, this is amazing. And who's actually gets to use it, like your teams use it at work in the work that you're doing. Yeah, right. Like we love it. Yeah, I know how that is. So I'll tell you a secret. I had somebody ask me after I was doing a talk similar to this. I love DDD. I'm learning all about it, but I can't get like I can't get people above me to get interested in it, or they're like it's too much work or anything. And I talked to a lot of people about it that raised that question with a lot of DDD experts, and the answer everybody said was event storming. So I will just let you, I'm just going to put that in your head. It has nothing to do with what I'm talking about here, but because every one of you is like, I love DDD, I'm not using it at work. So take a look at event storming. You might be able to open up some minds and eyes with that. But I'm going to talk about DDD and Entity Framework Core. And the reason I'm doing that is as EF Core has evolved, I'm constantly looking to see how well it helps us map our domain models to our databases, to our persistence. And it is getting better and better, right? So, as we were moving into EF Core 2.2, I've been, playing with it with EF Core and the EF Core 2, and each of the iterations to see how much closer it's getting us to having happiness when we're trying to map our domain models. So I'm going to be talking about how to bring those together. So you may or may not know that I've been doing DDD for about 8 years or so. The book's actually been out, Eric Evans' original book on domain-driven design. It came out in 2003, so this year's 15th year. So it took me a while to find my way to it. But I really have changed dramatically how I approach software development, not just the coding part, but even working with the clients. I've always had a real passion for learning about people's business and working closely with them, which has a lot to do with the part of domain-driven design that is about client collaboration. That really spoke to me because I already kind of had that passion. So that's what had pulled me into DDD, seeing that, like this focus on client collaboration. And then I started seeing more of the patterns, and it really has changed dramatically. So it's important to me to share that with people. So domain-driven design, domain is an important word. You're focusing on the domain. You're focusing on your business problems and not so much on these cross-cutting concerns. And people think it's funny that I'm like, Ms. Entity Framework, and I'm like all about domain-driven design because from the perspective of DDD, data, your database and getting data persistence in and out of your database, that is a cross-cutting concern, right? But that's okay. So that's one of the reasons that I actually spent a lot of time looking to see how Entity Framework and Entity Framework Core can help us do that mapping, because if I'm saying, don't worry about it, focus on your domain, I can also say, and I promise you, when you get to the point where it is time to do your persistence, you'll really be able to do most of what you want to do. So I want people to understand that it's okay. Like, don't worry about the data persistence and the mapping. We can deal with that later. Focus on your domain and write things the way it makes sense for solving your business problems. So I like to really like to stress like data persistence is a cross-cutting concern like some of these other things, like your DevOps stuff and security and things like that. So it's like stay laser focused on your core domain while you're working with it, and then when it comes time to do that data persistence, there's you get a lot of leeway with Entity Framework Core so that you don't have to have separate data models. So I talk a lot about the mappings, about dealing with that persistence after the fact, and that really focuses on half of domain-driven design, which is referred to as tactical design. Because I am so much talking about that only, I always want to step back a little bit and make sure people are really aware of the fact, that it's not just about designing your classes and mapping to your data persistence layer or, the coding part, the implementation part. The strategic design is equally important in domain-driven design. So that's the part where you're really, really learning about the business problems and strategizing about how you're going to be solving those. Okay, and this is when you identify, well, many of you said you're familiar with DDD. You identify your core domain and maybe secondary domains or external domains, as well as those wonderful bounded contexts, really identifying the boundaries around the different problems that you're solving so that you can focus on one problem without worrying about them, right? We're just going to stay within this boundary. And again, just like I'm looking at how Entity Framework Core can help us map that data afterwards, DDD already has all these great patterns for, if you're just focused on this thing at one point and just focusing on this, maybe this bounded context over here, DDD gives us all kinds of patterns for connecting them afterwards. So again, you don't have to worry about how you're going to, whether it's the data persistence or how you're just going to move data back and forth between these bounded contexts, because the patterns exist. So I just always get to tell my clients, just don't worry about that. I spend a lot of time going, it's okay. Calm down. You don't have to worry about it. So I'm all about de-stressing. So strategic is just as important, maybe more important than tactical design, but when it comes to doing the coding, the tactical design is equally important. So the tactical design is when you're really starting to implement all these discoveries that you made when you were doing strategic design. So this is when we really start doing the coding. And the client collaboration continues into the tactical design also. You don't just say, okay, we found everything we need. Now we're going to go and build our domain models and do all that work. You can still have them somewhat involved in the process. One of the reasons you're also able to do that is during strategic, we define something really important called the ubiquitous language. The ubiquitous just means it's like a glossary, the language we're using within a bounded context, but throughout all the processes. And that language extends into the code, right? So you don't have to go, well, this means that, right? We always are using this within a context, bounded context, we're always using that same terminology. So it is possible to have those domain experts, the people from the business, still be involved at that tactical layer, because you don't have to explain. They already understand the domain and the ubiquitous language, so they can be involved throughout. So kind of zooming in now on the tactical design. Those of you who have been already studying and learning about DDD might be familiar with these things. I'm going to focus on entities, value objects, and aggregates as I talk about these mappings. And also, yes, we use, it's entity framework core, but the definition of entities in DDD is not the same as the definition of entity in entity framework. It's just, kind of a coincidence, but really not, because an entity really refers to an object that has an identity, right? And so that's a big important piece both in DDD and in Entity Framework. I'll talk more about value objects and aggregates as I'm going through. And so I'll just keep track of this clock. So, being the entity framework, data persistence, this is a really important problem, right? If I'm focusing, laser focus on my domain, and thinking data persistence is secondary, it's not important, not worrying about what the schema of the database is, or what is a non-nullable value in the database, or any of those rules that we need, especially for relational databases. I don't want to worry about those when I'm focusing on my domain, when I'm designing that. But then what happens when it's time to go to the database, right? Like when you're thinking about the domain, you do not want to have the problems of the database influencing or impacting what you're doing when you're solving your business problems, because you start solving other problems and it adds complexity. Right, and you have side effects, and then you have this code that's all tangled up. So really, we just do not think about that at all while we're focused on the domain model. But at some point, we do want to get the data into the database and back out of the database. So how do we deal with that? The most classic way, the most classic approach in domain-driven design is that you always have a separate data model. Right? So you have your domain model, which really describes your business. You have a data model that maps really easily to the database. It's like a one-to-one relationship with how things are structured in the database. And then you have a mapping layer, some kind of a mapper, between your code, right? Your classes that describe your business and your behaviors and everything, have a mapper between that and the data model, and then a mapper between the data model and the database schema. Sometimes that can be overkill, right? Because if we have something like an ORM, maybe Entity Framework Core or Dapper, one of the ORMs, they actually can do a lot of those mappings. The ORM is the mapper, right? So we don't have to build an extra data model. If you think about the data model that Entity Framework creates, the DB context represents a data model. There's a data model right there. So quite often it's a smooth place to go, smooth transition to get from your domain, your classes, the way you define them and design them to solve your business problems, right? To get them into the database using EF as a mapper, then you don't have to have a separate data model. There's a point at which it doesn't work. There are some places, some scenarios where it just isn't going to work, and you start thinking, I have to go make a change into my domain model to make Entity Framework happy. That's when you have to back up and say, maybe in this scenario, it's better to just have a separate data model and have the mappers in between. So that's a really important thing to understand. So it doesn't have to be 100% of one or 100% of the other. You've got a lot of arrows in your quiver to choose from, right? I like to use the tools that are available to me. So I start, if EF core in this case is going to do it easily, then I'm happy to just use that and not have a separate data model and all those extra mappings. But I also recognize those red flags when Entity Framework is not happy. I can't find a smooth path to persist the data. That's when I say, okay, maybe in this case I'll use a data model. So now EF Core. So EF Core 1.0 came out, gosh, it's been over 2 years. It's really hard for me to not recognize it, but just like, whoa, really, it's been that long. And then EF Core 2 came out last summer. So that's been out for quite some time. And as EF Core 2 came out, it brought a really important mapping that EF Core 1, there was something missing. I was like, it's almost usable for me, but there's something really important missing, which was the ability to map value objects. Very important in DDD. I'll explain them in a bit. So that was a really big deal. And then EF Core 2.1 came out this summer, and actually a lot of the improvements in there gave us even more ability, more places where there was a smooth path from the domain models into the database just using EF Core without having to do weird things. 2.2 is coming soon, very soon. As many people are, maybe kind of hoping Connect which is what, like next week or something, in the next couple of weeks, that we're hoping that this is when, they're going to be like, okay, here's all the new .NET stuff. So, but that's coming soon. That has a couple of more kind of tweaky things in it. But the bigger point is that as we moved into the 2.1, there were 500 changes in there in GitHub. Some of them were bug fixes, but there was also some major changes. The difference between the version numbers, like if it has so many big changes and nice features added to it, why wasn't it 3.0? That's because there's no breaking changes, right? How the semantic versioning goes. But it did still bring us a lot of really nice stuff. So I'm going to go through a whole bunch of patterns so that you can see, if we're looking at this pattern, coding pattern in domain-driven design or a modeling pattern, how does EF Core do it? Now, if we had a lot more time, I've got a whole bunch of demos. I would probably be, debugging and testing and showing you a little more detail, but I'm just going to do it a little more high level so that you can see what the code looks like, but that we can cover more of the patterns. My model is somewhat simple. It starts with a team. So it's like a sports team, right? It starts with a team. A team has players. So the players change, right? They go to another team, or they have a hissy fit and get kicked off the team or something like that. A team has one manager, and managers sometimes change also. So managers, and they usually go from team to team. So a manager has a history of the various teams that they're in. So we've got different types of relationships here when we're thinking about, especially with like Entity Framework or even DDD, but just these relationships. So team has like a one-to-many relationship with player, has a one-to-one relationship with manager. A team has uniform colors. I added that into the model because it helps me demonstrate something, another really cool feature that came in 2.1. And then these person full names, these are representing the value objects that I'm using in my model. Okay, so I'm using this object, this person full name object, in both manager and player because they're humans that have names. I also want to say before we look at this code, and I realize that I came up with this the last time I was at Øredev in 2013, and I even tested it out on Twitter, like, will people understand? So in addition to loving domain-driven design, I also feel that I'm a big follower of ADD. Does anybody know what that is? I coined that. So, if you're doing the t-shirt, give me I need a cut because I invented that. Attention Deficit Disorder Driven Design. And that actually aligns beautifully with a lot of the patterns in DDD because it's all about controlling how anybody is interacting with your classes. I want to make sure that nobody uses things mistakenly, right? So I have to write my classes in a way that other developers who are using them will only be able to use them the way I want, right? The behaviors that I'm building in, the rules, the processes that I'm building in, like make no mistakes. So I'm not going to be doing this, but I want also to point out that as I'm building the mappings that go between my domain classes and the database, there are 3 levels at which I'm making sure everything works. First is building, right? Using .NET Build. I'm using a Mac, so I'm using Visual Studio Code in the command line, but you can all do all this in Visual Studio also. So building, that's a pretty good validation that you've got a lot of things in line. But I'm sure you've had code that builds beautifully, that compiles, and then you go to run it with something with Entity Framework, and at runtime Entity Framework complains about something. So I'm using, again, there are PowerShell commands for this you can use in Visual Studio. But I also validate the context. So with the command line, I'm using .NET EFDB context info. That just forces Entity Framework to read through the model and the context and make sure it comprehends everything, make sure everything aligns. So if there's a problem there, it will highlight that. So that's a nice way to validate that, rather than waiting for it to blow up at runtime. And then, of course, I have a lot of tests. I have tests that are just unit tests that are testing my domain model, those classes, to make sure that logic works. But I also have a lot of integration tests that make sure Entity Framework is doing what I thought I was asking it to do, right? Because that's when I can also find where I've made some mistakes as well. So that's my process for validating all of this stuff. So the first pattern I want to address is about encapsulating scalar properties. So so I've got these little, I created these little icons for the different patterns. So this one is about protecting your aggregate, right? So I have a team. I have my team class. As a matter of fact, let me show you what that looks like first. I have to put my glasses on because they're smaller here than they are there. Also, this code is up on GitHub, and the way it's organized is I just have a whole bunch of different branches. So I'm in the starting point branch right now. So I have a team class, and maybe how's that? Maybe make that just a little bigger. So anybody who's in the back row that says it's too small, there's a lot of seats up here. I'm not making it any bigger. So I have an aggregate, which is, a graph of data, right? I have a team. The team has players and a manager, right, and the uniform colors. But what's important about the way I've designed this is the team, all of that together, this graph is called an aggregate, and the team is the root of the aggregate. And what that means is the team class is in charge of the rules about everything that's happening in the graph. So if I want to add a player, the team class is in charge of the rules behind which a player can be added to a team or a player removed, right? If I'm adding a manager or firing a manager or getting a new manager, right? The team class is in charge of the rules of how the manager behaves within the aggregate. So I have these rules in here. So the team has a whole bunch of properties. Notice that they all have private setters, right? Because I don't want people just randomly changing things without my logic being in control of that. That's why I have a constructor, right, where I am supplying the most important pieces of a team. So it doesn't make sense to create a team, like instantiate a team and then set its property. Like, why instantiate a team that is invalid, right? So I'm passing in into the constructor all the values that it doesn't make sense for a team to exist without those values populated. So that's why I'm using this constructor. And then these values are private, right? Like, there's no way to change them unless, you go through another way. So some of this I've done a little extreme, right? Because some of the things that I've made private, I haven't created a way to say, oh, there was a typo, I got to fix it, whatever, sure, a little maintenance. But I just want to, give you kind of a bigger picture of this. So I have a list of players. That's not really very DDD yet. This actually annoys me. This was a big problem even up through EF6. It finally got solved in EF Core. I'll be talking about that shortly. They want to add a player, they have to go through my add player method, right? Except the way this is designed right now, they could still just go in here and change things, right? So that's something I want to lock down. I'll be doing that later. And manager, it's a private setter for manager, but if I do want to change the manager, I can go through this method, right? So the team is having control over how its aggregate works. And then player's mostly made up of a name, right? This person full name that I was talking about before. We'll look at it in more detail later. And that's really about it. And a player belongs to a team, but the team is controlling that relationship. And it's the same with a manager. A manager belongs to a team. The team is more controlling that relationship. Although I have a weird model because I can keep track of what the current team is, but I can also keep track of the past teams that they were on. So that's just trying to give you a high-level overview of that model. So I'm going to flip over to my encapsulate scalars. So one of the things I've done here, go back to team. I'm going to be flipping around a lot here. I've encapsulated the scalar, this one, this string that represents the team name, right? It was originally just a public string that I could have access to, and I could only assign it through the constructor. So now what I've done is I've used a backing field, and I've said I really, really want to lock down team name. You can never edit the team name, right? So I've really, really protected it. So I've done that by introducing a backing field, and then the team name is really only a getter, right? I can only retrieve that name. So what's interesting about this is if I had made this public, the backing field support in EF was introduced in EF Core 1.0, so that was great. And if I made this public, the EF Core convention would figure all of this out. It would understand that team name, that backing field, when it materializes, when you do a query and it materializes the data, it would be able to find this. Okay. But the problem is I've encapsulated it even further because I'm doing like really, really hardcore ADDDD here. And this is private. So reflection won't even be able to find it. All right. And so that seems like it's a problem, right? I want to design it this way for DDD, but Entity Framework won't be able to figure this out. However, Entity Framework Core does have a mapping that I can use to solve that problem. Okay, so I can say, so again, by convention, if the backing field was public and it was the same name, right, underscore team name, and team name was the property it maps to, Entity Framework would be able to figure out how to do that, but I've hidden it. I've made it private. So I have to go one extra step. But it doesn't mean I can't do it. It just means, thankfully, I get to take advantage of the Fluent API that gives me the ability to say, hey, by the way, I've got a property called team name, and I want to make sure that you know that there's a field, there's a backing field there. I'm just letting it know the backing field's there. I have to use a magic string, right? It's not available through Lambda because it's private. So that's how I can do that. I can really, really lock that down, have a backing field that's private so I can really control how things are working, but I can still make sure Entity Framework understands what to do when it's saving it to the database and when I'm retrieving that and it's materializing. So that's really nice to be able to do, in my opinion. So the next thing, this was really, really important. We are now able to encapsulate collections with Entity Framework Core. This was a problem that had no solution, no beautiful workaround in Entity Framework 6 or earlier. So I'm going to flip to this branch. And what I've done here with team, remember I kind of mentioned quickly before that I had this nice add player method, but it was still possible for developers using my classes to get around that, right? And I just had to go, please remember to do it, please, please, please. So that's very, very unsatisfying. So what's really nice is EF Core, with EF Core 1, Entity Framework now recognizes IEnumerable, right? So this is a typical pattern that we use when we're doing DDD to encapsulate a collection, but we couldn't do it with Entity Framework Core. It only, when you're materializing data, it only recognized list and iCollection. So it wouldn't have seen this players. So even if you were retrieving players along with a team, it wouldn't populate them. They would just never come back. So now it recognizes IEnumerable. So I've got my property players IEnumerable, right? But I'm still protecting it with this I'm using a backing field for the collection. So it's all really protected. Nobody can just go in there and add a player through here, right? And they don't have access to underscore players either because, again, I've made the backing field private. So I've really forced the developers using my APIs, they have to go through add player. There's no way around it now. And again, I've created a little bit of a problem for reflection by making my backing field private, right? So mapping, there's a mapping to get around that also, but it's a little different. Here's the mapping, remember, for the scalar property. And now here's the mapping, actually a pair of codes of line I'm using to solve the problem for the collection. So I'm identifying the collection property, which is team players. So I'm just saying, okay, I've got a navigation, drill in here, and you can find it. And then once I've identified that navigation property, I'm using a method called set property access mode to a field. And in this case, I don't have to tell it what the name of the field is. It will find the field because I've named it using convention. The field is underscore players, which matches the property name player. So by convention, it will use it. If I had used a different field name that didn't follow convention, then I can just add this has field method and solve that problem. So now we can totally encapsulate collections. Entity Framework respects that. So mapping value objects. Boy, 40 minutes goes way too fast. Value objects, I like to usually spend a little extra time talking about value objects because it took me like a year to understand them, really. I heard like 5 different explanations of them. So the top level attributes of a value object are they don't have their own identity key. They have to be used as a property of an entity, right? So they're a property, and it's an object that has a bunch of its own properties. And then it's because it doesn't have its own identity key, the way you identify one object so you can compare to another object to see if they're equal or not is that it's composed of all the values of all its properties. There's actually a few more attributes, but I have a couple of examples that I've used to try to help people understand them. So string is a perfect value object. It's composed of the letter, of a bunch of characters. So in this case, I have the letter R, the letter A, and the letter T, and they represent together this little vermin. Some people like them, some people don't. He's kind of cute, actually, that one. But the value objects are immutable, right? Because if you change one piece of a value object, one of the properties, then the entire identity, the entire representation of what that is, completely changes. So there I'm just changing one letter, right? And now I got something completely different. This is what it represents now. So it's the combination of those properties. I change another letter, I get something different. Value objects are really important in financial systems because the representation of a value, a monetary value, it really is a combination of different things. So I could have 45,000 crowns, right, which I could use to buy a commercial edition of a HoloLens. But if I had $45,000, I could buy a pretty nice car, right? But it goes even further because if you think about, how the financial systems work, even adding in the moment in time, the values, what that value represents is different. So they're really important for finance. So looking at a value object, so that in this case, I've encapsulated it in a way so that the properties are immutable, right? The only way to set these properties is through the constructor, right? If you need to edit it, you don't edit it, you create a new one, right? It's immutable. Another important thing about value objects is like the whole point of this is so I can build up some behaviors and properties that I want to reuse, right? I'm using this in the manager, I'm using this in the in the player. I don't have to repeat all of this logic every time, right? And then finally, another important facets of value objects is that you have to be sure to override the equals so that when you compare equality, that equals will compare all of the properties, right? Instead of the way like .NET does it. So you're overriding equals and you're also overriding the get hash code. And I'm also doing operator overload. So I'm making sure anytime I'm doing comparisons that it's comparing the entirety of that object, all of the property values. So this is such an important piece of domain-driven design. And as a matter of fact, you'll find if you really start thinking about it, that a lot of the places where you thought you had a one-to-one relationship, if you try to always consider a value object first, that's just my warning. It's also vibrating on my arm. Okay, stop. If you, yeah, that was distracting. So the value objects, the attributes of it are really, really important. And what's really nice is, I was talking about one-to-one relationships. So the value objects, you're more likely to have a value object where you think you have a one-to-one relationship, because that the subject or the dependent in that relationship really is defined by the entity that it lives in. It makes more sense as just a straight property, not its own separate object with its own identity. It doesn't need its own identity to track it like you would have with a key. So Entity Framework Core introduced in 2.0 this concept called owned type. Okay, it aligns. It doesn't work the same way at all, but it aligns with what we knew as the complex types in earlier versions of Entity Framework, right? And that disappeared when EF Core first came out, and we were like, how are we going to map our value objects? So this isn't here for the sake of value objects, because it actually it does solve mapping value objects, but it also solves mapping simpler, something that's a complex type that isn't necessarily a value object with these other attributes of immutability and the equals. But what they have in common is no identity key, and it's used as a property of an entity. Now, Entity Framework won't recognize it by default. You have to supply a mapping for doing that. So that's what I've done here. Map value objects, team context. So here I've done that for both the player. I'm saying the player has a property called name factory, which is the person full name type. So the player has it. So when you're looking at player, that property that you see called name factory, that's owned. Right, so Entity Framework will know how to map it, and by default, it will put it in the same table with the entity. And also, Manager has a property named Name Factory. We want you to understand that this is an owned property. Now, we're also getting owned collections, so you can have collections of value objects, but they moved that from 2.2 to 3.0, so we're not going to get that quite yet. One-to-one was always aggravating because we had to really dirty our objects in order to be able to map them with Entity Framework. Entity Framework 1 through 6, they required that we had to have the navigation properties, whether we wanted them or not. That's one of those places where I'm like, I don't want to put them in there, and I have to put them in there for Entity Framework. Right? And I don't want to care about Entity Framework. There was literally no way around it. So now with EF Core, it's so much smarter. It understands by convention, it understands the basic one-to-ones. It will find them by itself, so you don't have to add this extra mapping. Right? And we had to do that mapping to identify the principal and the dependent. And in order to do that, we had to have the navigation. So it just recognizes it by default now. So that's already nice, but I want to make sure you understand, even with this, which is more complicated, you can still use a backing property, right? A backing field, not property, backing field, and you can hide that backing field, which means there's a mapping for that as well. So I'm probably going to spend more of my 40 minutes switching from branch to branch here. It's like using the branches is like really, really clever, but then all of a sudden you're like, they're all over the place. So here's a mapping. So also the mapping terms, the mapping methods have changed. The names make more sense. I can't even remember. It was has principal with dependent or something like that. Now it's just has one with one, right? So they simplified that. But there is a way, if you've encapsulated the one-to-one child property in your entity, there's a mapping for that also. So this is, you identify which relationship it is, and you have to identify the foreign key. So again, I've completely hidden that. Here's team. The one-to-one relationship that I'm hiding here is for the manager. So I went from just having a getter and a setter to introducing the backing field on manager, and just totally encapsulating that. The last thing I want to show you very quickly, actually oh no, I've got it described pretty well here. Mapping many to many, it's not really like a DDD thing, but it's important to know if you haven't used EF Core. Right now, we don't have that magic that EF Core Entity Framework used to give us. You have to have an explicit join entity. So if you're looking at a relational database, and you always have to have that join table in between, Entity Framework magically made that. I hate magic anyway. So now we have to explicitly have that. Maybe someday they'll bring it back, but I just want you to be aware of that. And then just like this isn't new, but you have to map the composed key of the join entity, and then it will work. Value conversions are really cool because this is also important for DDD because you can use the types that you want instead of only using types that have a data type that they can map to really easily in the database, because there's a lot of things. Colors, to me, is like the perfect example of that. So what value converters do is you can have a .NET type that doesn't have a natural mapping to the database. You can tell the context that what you want it to switch to a different .NET type just before it goes to store it, and then DB EF Core will go, oh, I know how to map that type. That goes to a string, or that goes to an integer, knows what to do. And on the way back, it's the same thing. The data type comes back from the database. You've got instructions to say, this is coming back as a string, but really I want it to be, this other type that doesn't happen to have a string. So I've got that with the colors. I know we're ticking here. Value objects. So I'll just show you one example of that, which is in the context. So I have the uniform colors, and the uniform colors, I'm using colors that are all color, right? Color doesn't map to a database type at all. So I've got this mapping. Is it way up here? Where's my mapping? Where's my color mapping? Okay. I flipped to the wrong thing. I've got an example of it here. Okay. So there's a has conversion method now in DB context that you can use, and there's a couple of different ways to use it. So you can pass in, for example, its color. You can pass in a method that says change the color to a string, and then it knows how to map the string to the database. Now it's stored in the database as a character. When it comes back, it's going to see the character, and then you have the other half of has conversion that tells it what to do when it's coming back. So you'll say, whatever string you find, use the color method. The color has a method called toColor, and you pass a string in. So you just put that method there, and then it converts it back to a color. And you can encapsulate that in a variable. You can encapsulate that in your own class. There's even 15 built-in converters. I think it's about 15 for like enum to string, so you don't have to do all that extra work. The last thing I want to make sure you're aware of that came in EF Core 0.1 is something called shadow properties. This is awesome for having audit data, so you don't have to put your audit data into your domain classes, like date created, who created by, etc. You can define those literally in the DB context. And then in the DB context save changes, you can say, you can populate them. I will steal one more minute. Or I could pretend I thought this stopped at 5. No, I won't do that to the next person. Shadow properties, just so you can see what they look like. Oh, there's the uniform colors. So shadow properties are, come on, too many things. Here they are. So these properties created in last modified do not exist in my domain classes. I'm telling the context they do exist, even though they don't exist. So the context is adding them into its in-memory model. And then when I'm saving changes, I'm just saying, if it just got modified, set the last modified date. If it's brand new, set the created date. and then that stuff gets stored in the database, so all your auditing reports and things like that, you have access to that data, but you don't have to put them into your domain model and then also deal with them in your business logic, which doesn't make any sense at all. So that is the list of what I wanted to show you. So I say go ahead and write your classes the way DDD teaches you to, and you can really use those patterns. EF Core 2.1, and coming forward we're going to get more things. Most of the time you're going to be able to, it'll either map by convention or there's a mapping that you can use to get that stuff in there. And when there really are gaps, look for workarounds, or if it's just, it's just not going to happen, then use a data model and use the mappers in between domain model, data model, and entity framework. So thank you very much for your time. This is all going to be, I've got this online on GitHub, the demos and the PowerPoint, so you can take a look at those resources. All right, I got to move out of the way for the next person. Thank you so much.